Now, to set the scene for this, our first speaker, I'm very pleased to welcome all the way from Colorado in the United States, Dr. Adam Warren, who works with the National Renewable Energy Laboratory of the United States. Now, this is the National Laboratory of the United States Department of Energy. So you can imagine what a role it's playing in working on the clean energy initiative in the United States. Now, Dr. Adam Warren, works in the water and energy nexus, he tells me, which I hope is a comfortable place to be. You're going to be nice and warm and possibly wet as well. And he's going to be talking now about how the latest thinking about reducing CO2 emissions in water desalination. So will you please welcome Dr. Adam Warren.
Good afternoon, everyone. I'm glad to be here. I'm going to thank my partners at Masdar and IWS for the chance to come and share some of our work with you and to talk about this newly formed Global Clean Water Desalination Alliance that's just underway. If you're not familiar with the National Renewable Energy Laboratory, it's the only U.S. laboratory focused 100% on clean energy. It's energy efficiency and renewables. We've been around since Carter, basically, about 40 years. And for many years, we were focused just on those two topics: energy efficiency, how to make your systems more efficient, and renewable energy, wind, solar, and other things. Lately, we've really looked in the last decade or so more on the integration of systems. So energy system integration. And more, we recognize that the energy-water nexus is a very important thing to understand and to be able to tackle the challenges of if we're really going to get to a sustainable energy future. As we all know, there's an energy-water nexus. It takes energy to make water, whether you're cleaning water to desalinate it or you're cleaning wastewater, and it takes water to make energy. So you're cooling, you're using it in cooling, using it to clean systems. So that nexus is challenged by the fact that as climate change occurs, you've got this other loop, right? You've got energy production, fossil fuel energy production is leading to climate change, which is stressing our water systems. So what I want to talk to you today, I want to start it off by giving a bit of motivation for the work we do in the energy-water nexus, and also talk about the motivation for the Global Clean Water Desalination Alliance. And hopefully I set it up for the next panel so they can discuss some of the details. So before I start, has anyone heard of GRACE, the GRACE satellites? A few? Okay, a couple. So the GRACE satellites were a system that were put up about 15 years ago almost now. And it was a joint venture between US NASA and a German research institute. And it was this interesting thing. What they did is they sent up these two identical satellites, okay? And these satellites orbit the Earth in a polar orbit. They're going around the world in a polar orbit, and they have a laser interferometer between them. What does that mean? They've got a really accurate ruler between them. So they can tell to within millimeters, micrometers, how close these two satellites are orbiting the world, okay? So why am I talking about satellites if it's water, right? Well, what those satellites allow you to do is as they come onto a mass, like let's say a continental shelf, the first satellite sees more mass between it and the center of the Earth, and so it speeds up a little bit, right? So that gap between the two satellites grows. Then the next satellite comes, it sees that same mass, it catches up. So you can see, as you go back and forth, what you're doing in an inadvertent way is you're measuring the amount of mass between these twin satellites and the center of the Earth. So what do we learn from that? These guys have been going around and around the world for almost 15 years now, and they're watching the mass of the Earth actually change. So, what can they tell? That we can't just tell by looking at water on the earth or looking at glaciers. They can tell that that guy's taking water out of an aquifer to grow plants. And in fact, in some places, they can actually look at how much biomass. So they're going around the world all the time, and they're recording the changes. What are they finding? I think we probably all know, since we're in this room, what they're finding. They're finding that we're using all our groundwater. So here's the U.S. In the California Valley there, the Central Valley, we call it in the U.S. That's where we grow a lot of the produce for the U.S. Almost all the almonds we eat in the U.S. elsewhere are grown there. And what are we doing? I'm sure you've probably heard the stories. We're pulling more and more groundwater. So every year, those farmers are having to drill deeper and deeper. And you see how aggressive this is. It looks like to get out of the current drought we're in, we need 11 trillion gallons to replenish just this water. That's a lot of water. Well, it's happening everywhere. There are a few people in the U.S. There's 300 and some odd million. Some of those are in California. How many people are there in China and India? Right? Almost 3 billion. And they're seeing the same thing in India and China as well. So this is us pulling the water out of the groundwater being fed by the Himalayas. And the World Research Institute estimates that 54% of India's groundwater wells are decreasing right now. Let's switch to MENA. As you all know, we're pulling the groundwater out of the aquifers here as well. So here, inches of water, you can see particularly in the Arabian Peninsula and north, we're down up to 10 inches of water. So will desalination cure all this for us? I think we all know, because we're in this room, we know water systems, it won't. But it's going to be an important part of the overall solution, right? And so that's why a group at COP21 set up this Global Clean Water Desalination Alliance, okay? It was launched at COP21. The Alliance is one of the initiatives under the Lima Paris Action, and it's open to all categories of actors. That's important, because it's not, we engineers, think it's like Field of Dreams, right? If you build it, they will come. That's not true. You need the full system, the policy, the business models, the technology to get these systems corrected. So this is an alliance that's been opened up, and it's still in its growing phase. We'll have a meeting this afternoon about it. It's something that you don't have to, you have to give a commitment, but there's no financial commitment, there's no legal commitment, but something that we're trying to with Masdar and IDA and the French trying to stand up. So like I said, this alliance is focused on the full system. So the technology, the policy, the business models, and these are the groups that we really need to engage if we're going to solve this problem. So it takes a wide swath of expertise and focus to address clean desalination. So how do we reduce the CO2 emissions associated with desalinating water? So there's 4 focus areas that we have. There's 4 moving groups. Overall, like I already mentioned, it's a holistic approach. We're looking at research and development. We're looking at capacity building. That's very important. And we're looking at short, medium, and long term, and I think that's important too. So this conference, as we discussed yesterday, is about action. So what are the actions we can take today? What are the R&D opportunities that we need to identify so we can address those tomorrow? So we try to keep a balance of that. And we've got 4 different streams. We've got clean energy supply. So within that water energy nexus, what can you do? You can make the energy supply cleaner. You can make the desalination system more efficient. And that's the second one, the second work stream. That work stream is also looking at the integration of energy and water systems. I'll talk a little bit more about more of that later. Then we got 2 work streams, one that looks at research, development, demonstration, deployment writ large, and another stream that just works at education, training, capacity building, okay? So the overall objective of the Alliance is to stimulate reduction of CO2, as I mentioned, from water desalination, and to promote the policies that do support that. Here's some of our specific goals: 20% clean energy supply for new plants, 40% clean energy supply for new plants by 2030, and it continues to increase. I want to give you a feel for the groups, because we're going to have a panel that is after this that is engaged with this, so I think you'll see some names you probably know. The board and directors, they've chosen it so that we represent 4 different regions and 4 different foci, if you will. So the different regions you can see up there: government, industry and utilities, financial institutions, and researchers are the different segments. Right now, here's who we have as of June 2016, who's signed up. As I mentioned, we have a meeting on Thursday, and I'll talk about that later. If you're interested in this, you can sign up with us. I'll skip this in the interest of time. All right, here's some of the initial work we've done. We had to work at Massachusetts Institute of Technology. There was 11 participants. There were several participants, 11 nations represented. We pulled together this report that you can download here. And what it looked at was, okay, how do we get there? What are the R&D and demonstration needs? Basically, the report looked at 3 areas: energy storage and transmission, energy efficiency, and desalination. And what we did is we looked at the different immediate and long-term tactics for cleaning the grid, which is this top one, and we looked at what's the impact if we could deploy more broadly these clean energy technologies, and what is the technology maturity of those technologies. So you can see what should we go implement and what can we do R&D in. Same thing in the bottom left-hand corner for technology readiness and impact of more efficient desal technologies. And then in the bottom right-hand corner, this talks about if you've got a desal system and you're trying to deploy it on a grid that has a lot of renewables, what's important? Those of you who are in utility understand that what's important is to keep your generation and your demand at balance at all times. If you don't do that, the grid goes down. You can do that one of 2 ways, one of several ways. One is you can always flex your generation to meet demand. The other way is you can control your demand. So if you've got a lot of wind or solar and suddenly that drops, you can ask your desal systems, if they're properly configured, to drop their load. Or you can ask your desal systems, why don't you make clean water at night when electricity is cheaper? Those are some of the integration things we're going to be looking at over the next few years. And I think I've gone a little long, but if you're more interested, this is where the meeting will go next, or come talk to me, come talk to Leon, or any of the other panelists. Thank you.